Hello everyone. Today we are going to discuss and design and analyze the retaining wall structure. Normally, retaining walls are mainly used for the retaining of the water, soil, etc. so that it can be retained. So these are mainly helpful to resist the forces which are overly applied in the structure. So retaining walls are important so to make the structure stable and it prevents from failure. So retaining walls are mainly used at the hydro sites. So let us go for the STAAD programming interface, in which we will be designing and analyzing the structure. So let us click on new project. Let it be named as let us select space. Then let us go for here and let it be named as retaining wall. Retaining wall. Okay. Next, let the length units be in meters and force units be in kilonewtons. Click on next. Let us select an add beam. Click on finish. Okay, it's been finished. Let us wait till it is loaded. So then now we have to provide the length from here to here. So click on escape. So we have to draw a beam. So let us go like this one. So after drawing this beam, we have to select this beam. So after selecting this beam, we have to go for the transitional. We have to produce in Z direction. The number of steps is 1. Let the spacing be 5 meters. Then click on link steps. Click on OK. So here you could see. Here you can see the steps have been. That means the plate has been created. Now let us select this one. We have to provide the foundation for this retaining walls. So let us copy this one and paste this one. In X direction, let it be 2 meters. Or also you can also take it as 3 meters. Then click on OK. Next we have to copy this, copied already, and we have to paste it in the direction of 2 meters. Then click on OK. We have to paste it in the direction of minus 2 meters. Then click on OK. Then we have to paste this towards the downside. Then click on paste it at the downside of minus 2 meters. So then let's click on OK. So here it has been created. Now our main aim is to draw the plates. So we'll be going to draw the add 4 nodal plates. Then click on this one. Here. A plate has been added. Here also you can add, so that it has been added. Next, okay, it has been added. So here the plates has been added. Then let us select all these members and we have to delete it. So click on delete, click on OK. So it has been deleted. Okay, in this way it has been deleted. And also we can also produce this retaining wall somewhat big also. So then let us go for this select and select the plates. Then click on transitional repeat. Then let it be in Z direction. Let the number of steps be 5 or 4. Default spacing be 5. And click on link steps. Click on OK. So in this way it will be drawing. So here we have to delete and select and delete all the beam members. Click on delete, click on OK, and so it has been deleted. You can also see in this rendering view. So in this way the retaining wall will be there. So here you can see it. Then close this one. Then we have to, so the geometry has been completed. Next, so next we have to produce these plates. That means we have to go for the geometry. In geometry we have to, in general we have to give this properties and supports and loads and thickness. For properties we go here, we are going to define this plates thickness. So let us go for this thickness. So first of all let us take this thickness as point, it will be named as 0.20, and the third and fourth node be 0.40, and it will also be 0.40. Click on add, click on close. So it has been added. Then again we have to add this other one, it will be 0.40. Then click on add, click on close. Okay. So after that click on save, click on save as. So then now we have to go in this top view. We have to select those plates. And we have to, let us select these plates. Let us select all of these plates. So after selecting this, we have to provide this thickness. Okay. And let us select in the top view. Here you will clearly see that all that has been selected. We have to give this plate thickness. Then click on assign, click on yes, it has been added. Next, let us go in this right key option. We can select all these plates. All the plates have been selected. Else select all of these plates. Sorry, you have to go to this one. Select all of these plates. So then click on assign to selected. Then click on yes, has been assigned. Okay, this way it has been assigned. You can see in 3D rendering view. Here you can see. Here you can clearly see the 3D rendering view of the retaining wall. Okay. Next, let us cancel it. And next we will be going for the supports, adding the supports. Click on this one. Click on this top view. Or else we can give supports here also, but we are going to give at this ends only. So let us select this node, and this node. Sorry, first of all we have to create the supports. We have to select this one. So then let us select these nodes, this one and this one. Click on assign, click on yes, assign. Here you can see we have to assign this to the everyone. Here you could see this one. So all the supports have been assigned. If you want, you can also give to this side also, but I am not giving. So back side also you could see, from front side. Okay. Then isometric view. Or else you can also give up here. So here you could see. Okay. And this way it has been done. Then let us go for, after giving the supports, let us go for this loads and definitions. In loads and definitions, only the hydrostatic force and the dead load of the, that means the self weight of the retaining work is taking place. So let us go for the load case details, then click on add. Firstly, we have to add the dead load, that is the self weight. It will be named as DL. Click on add. Next, let it be named as the live load, that is hydrostatic load. Let it be named as hydrostatic load. Click on add. Click on close. Okay, this way. So let us go for this dead load and let us click on add. In dead load, we have to add the self weight. Then click on add. Click on close. Okay. Select self weight. Click on assign to view. Click on assign. Click on yes. Okay, it has been assigned. Then go for the hydrostatic load. Click on add. Click on plate load. Click on hydrostatic. Then we have to select those plates. So we have to select the plates. So for this we have to select the plates. Okay. So let us select all of these plates. So let us click all of this one. Click on done. Let it be was the let it be okay. Let us save it. Then let it be minus 40. Then let it be in y direction. Click on add. Click on close. Okay. So it is done. Let us click this one. So in this way, the forces are acting here. So if at all, if you get any errors, we go and rectify later. And click on for the material. And click on the concrete. Click on assign to view. Click on assign. Click on yes. Again assign. Next we will be going for the analysis. Then go to analysis and perform analysis. Click on add. Click on close. Then we will be analyzing the structure. Then go to run analysis. Click on save. Let us see the structure. So here you could clearly see that we are getting 0 errors, 0 warnings and 0 notes. So then let us click on done. Okay. Next we will be going for the design check. In design check we will be designing this wall, that is the retaining wall. Click on select parameters. Firstly we have to select this concrete. In concrete we have to select the parameters like compressive strength of the concrete. Click on transfer. Then reinforcement. Click on this one. Then if you want you can take this shear reinforcement, but it will not be required. Then click on OK. Then click on define parameters. It will be named as 30,000. The value be 30,000. Then click on add. Then go to main reinforcement. The yield strength of the steel will be 5 lakhs. 3, 4, 5. It will be named as 5 lakhs. Then click on add. Click on close. Okay. After that it has been given. Then let us go for the command. Let us go for the design of the slab element. Click on add. And then let us go for the takeoff. Click on add. Click on close. Okay. After takeoff, let us use in this one and then to view. Assign. Yes. F5 main. Click on assign to view. Click on assign. Click on yes. Next design element. Click on assign to view. Click on assign. Click on yes. Okay. It has been assigned. Next we will be going for the analysis and print option. We have to add this perform analysis. Click on add. Then click on close. Next we will be going for this for the analysis option. You go to analysis, then run analysis. Let us save this one. Let us see that if we are getting any errors, so we are getting 5 errors, we have to rectify those errors. So let us see what are those errors. Okay. Let us wait till the errors will be loaded. Okay, and since it is not showing, we will be going and running the analysis again. Done. Here we can see what are the here the design moment exceeds limiting moment of resistance for elements. Okay. So we have to delete this one. So let us go and let us go for the design model. Let us go this one here. So concrete take for the design element. Let us delete this. Sorry. Let us delete this command. So we have to again add it. Then go to concrete design. Then let us go to commands, click on slab element, click on add, click on offer. Then for this slab element, we have to select this tab and go to top one. So after selecting this one, click on assign. Yes. Now it has been shown. Let us go for the analyze and print option. Click on add, click on first. We have to analyze this structure. Okay. Let us. So for that errors to be rectified, we are going to delete this parameter design element, and again we have to add it. So click on yes. It has been design element. Click on delete command. And yes, okay, deleted. Let us go for this command and we have to again edit. Then go for this concrete and we have to add this command. So let us go for the design of the slab element. Click on add. Click on close. Okay. After that, click on yes, click on save, and go to let us then go for the design element, selecting the design element. Then we will be selecting these plates. So let us select these plates. We have to select all of these plates. Okay, we have to select in this way. So after selecting this, you can clearly see it. Then we can apply the design element to selected place. Click on assign, click on yes. Okay, it has been assigned. So next, let us take out, click on add and close. Takeoff has been assigned completely. So automatically it has been assigned. Let us go for this analyze and print option. Click on perform analysis, click on add and click on close. Then we have to analyze this one. So let us save it one. So let us see that if we get any errors. So we are getting 0 error, though our structure has been successfully designed. So click on go to post processing mode and click on done. Then click on this apply, click on OK. Okay. In this way, the deflection we will be seeing in this way. Here you could see there is the displacement. We will be seeing here. You can here you could see this one. The displacement in this way we will be seeing the displacement. So for bed load we are having no deflection, only for the live load it will be the deflection in this way. Okay. Let us go for this one. So okay. Next we will be going for this beams. Let us select maximum absolute low stresses, then click on apply and then click on OK. So here you could clearly see that the pressure will be more here all the way, because here the pressure is more. The hydrostatic force will be applied more here. so that the bottom will be receiving very less. Okay, next will be, let us go for this dead load. Here in the dead load only the bottom portion, see here you can see this, only the bottom portion will be receiving a heavy load. So there are only two loads will be acting. Then let us go for this animation. In animation, then go for the deflection, click on apply and then click on OK. So here you could see here whether we getting any deflection or not. Let us go for this. So here you can see this one. So in this way the deflection will be caused when the hydrostatic load is acting. Then it is the dead load will be acting. So here you could see there is no such deflection. So next we will be going for this modeling, and here we will be seeing this in a 3D rendered view. Here you can see, here clearly you can see the retaining wall will be constructed in this way. The top diameter, the top measurement is less than the bottom, and these are the footings will be provided, that means the plates will be provided beneath the ground so that the structure is stable. Here you can see, here you can see that the top measurement is less than the bottom. This side, all of this from here up to here, all of this is buried into the soil to make the arc to receive the force, to resist the forces will be acting. Okay, after, so in this way it will be, yeah, okay, you can see here. So in this way the design and analysis of this retaining wall will be done. Then let us go for the designing of this foundation. Here and here the foundation will be designed. Let us go for this foundation designs, and for the foundation designs we will be including all the load cases. Then click on start foundation. Let us wait. Till the start foundation sheet has been loaded, and let us go for here load 7 factors. Let us go for the generate load combination. We will come back continuing with the Indian standards, and let us go for the generate load combinations. Click on OK and generate load combinations and click on OK. Then let us cancel it. Here the load combinations are provided. Then let us go for the job setup. Then we have to create a new job. Let the job be named as retaining wall. Click on India, click on SI units. Let us import all these loads and click on create job. Let us wait. So here the selected footing job has been created. Then go to design parameters, then go to concrete and rebar reinforcement. So this is the unit weight and the minimum and the maximum facings of the bar is done. This is the illusion, that is the FI 415 steel is used. Then cover and soil, these are the cover and soil. This is soil type selected in drain condition. This is the footing geometry. These are the dimensions. This is the against sliding and overturning. Let us go for the design set of the footing. Let us wait. Let us wait for the design progress report. So here you could see the number of footings will be provided is 30 footings, 30 isolated footings. With here the length of the footing is given in this way, the length and the width and the thickness of the footings are shown in this way. Here you can see this one. So the reinforcement is provided as shown in here. So this is the isolated footing and this is the elevation, that is top elevation. So this is the footing geometry, column dimensions, pedestal, design parameters, etc. are taken. This is solid, and mechanical effects, loads and combinations, etc. Let us go for this detailing for this footing. Here you could see. So this is the footings diameter with 10.40 meters. So etc. Then this is the GA drawing sheet. Then click on this. So this is the footing sizes. Okay. Only the 4 footings with the form will be drawn. So here you could see this one. In this way the footing design will be drawn. Okay. So let us click on cancel and let us save it. Next we will be seeing this in a 3D rendered view. Here you could see clearly, you could see. Here you can clearly see this one. Okay. In this way you can see this. So the you can clearly see this one. Okay. In this way the design and analysis of the retaining will be done. Okay guys, thank you.